So here we have another vector application problem with an airplane, because they're wonderful to do with airplanes. So we have an airspeed and its heading, and then we have a wind blowing from 20 degrees east of south at 60 miles an hour. So what's the plane's course and ground speed? Okay, I made a video earlier using the same type of a problem, but using the law of cosines. Okay, now this one I believe is a little bit easier to do with the law of sines. I mean, not sines, but rather changing it into a linear combination, writing it as its component. So I'm going to do this one in that method. And if you like the law of cosines, then you can use that method, whatever you want to do. Whatever is easiest for you. So 240 degrees from due north is right in here. So due north on all of these airplane application problems is 0 degrees. We go clockwise from due north. So 580, let's make this the 580 length. Okay, and now we have the wind is blowing from 20 degrees east of south. Let's talk about what that means. So 20 degrees east of south, here is east and here is south. So 20 degrees east of south means I start at south and go towards east 20 degrees. Okay, that's what 20 degrees east of south means. So we start at south directly here, and then we move towards the east for 20 degrees, and then we stop. So this is where that airplane, rather the wind is blowing from this direction. So we don't actually draw it until we get to the origin. So there's my wind vector from the origin, right, where it meets that airplane. And this is blowing at 60 miles an hour. Okay, so using the parallelogram method, I can move this over to here so that we can have a decent idea of where our plane or our resultant is actually going to be. So this is our resultant. This is what we're looking for. What is the length of this line, or rather the speed of the airplane, and in what direction is it headed? Okay, so that's what we're going to do here, but we're going to use the linear combination method. So we're going to have two things. Number one, we're going to talk about the plane. So the plane is on a 240 degree direction, and it's going this way 580. So what we're going to do is we're going to change this, or rather write this into its components. So we're going to find the x component of this thing, and we're going to find the y component. Okay, the vertical line and the horizontal line, where this 580 is now the hypotenuse of that right triangle. So we need to figure out what this angle is in order to do that. Okay, so we know the whole entire thing is 240, and exactly west is 270, which means this little angle in here has to be 30 degrees. Okay, whenever we're trying to make a linear combination, we have to use the angle formed with the x-axis. Okay, because notice that's where our right triangle is. So we always use that right triangle. And we figure out this linear combination by taking the magnitude, multiplying it by the cosine of the angle. Okay, that gives you the x component. And we're going to get the y component by doing a similar thing, only multiplying it by the sine of that angle. And in a linear combination, the y's get j's. Okay, now it's really important to remember that this is the third quadrant, where both the x and the y's are negative. So our answer is going to be a negative x, and it's going to be a negative y when we write this in a linear combination. Okay, and that's important to remember when we're doing these problems in linear combination. So 580 cosines of 30 and 580 sines of 30 means we have a negative 502.3 x component, and we have a 290 negative y component. Okay, so those are the components of my airplane in a linear combination form. So negative 502 to the left and negative 290 down are the two components that would give me a 580 hypotenuse. Okay, so now I'm going to do a similar thing with the wind. So let's see, let's go over here in a clean space. The wind, remember, was blowing from 20 degrees east of south, so the wind was going this way. So we're going to take this one and also break it into its x component and its y component. Okay, remember, this was 60. So I need to know what this angle right here happens to be. Okay, so let's zoom in here. All right. So this was a 20-degree angle here, because remember they said it was 20 degrees east of south. So that one comes over here as a vertical angle, which means this angle has to be 70 degrees to make our right angle here. Okay, so I'm going to use 70 degrees when I do my wind vector. So the wind is negative, right? The x is negative, so negative 60. Sorry, let me erase that. 60 is the magnitude, so I'm using the magnitude, or the miles per hour here, 60 times the cosine of 70, I, plus, it's plus because in the second quadrant y is positive, 60 sines of 70 j. It's important to get the positives and negatives correct. So this is a negative 20.5 I plus 60 sines of 70, 56.4 j. Okay, so this is my wind component. So if I take my wind component down here to my plane component, I'm going to add these things together. So 20.5 I plus 56.4 j. Okay, so I'm going to add these two together. 502.3 plus 20.5, since they're both negative, gives me a total of negative 522.8 minus, because that's 90 is 290 is bigger, 290 minus 56.4 is 233.6 in the j's. So that's the linear combination that represents my airplane. So now I find the magnitude of my airplane, which would be the ground speed, by little Pythagoras. So I square the x component, and I square the y component, and that gives me my magnitude, after I square root everything, of course. So this plane is flying at a ground speed of 572.6 miles per hour. Okay, now to figure out the course, I'm going to figure out what this angle is, right? This was 522.8, and this was 233.6. So I can find this angle by using the inverse tangent. So the inverse tan of the y value over the x value. Inverse tan, 233.6 divided by 522.8, means that angle is a 24.1 degree angle. Okay. Now if I subtract that from 270, since that's my next whole value, 270 minus that means the plane has a 245.9 degree course. Okay, so what was initially 240 is now over here at 245.9 degrees, and the plane is flying at 572 miles per hour. So a little bit slower and a little farther to the west.